Welcome back, everybody, for another deep dive with us. Today, we're going to be taking a look at DeepSeek V2.
Mm.
As always with these deep dives, we really want to go into the technical nitty-gritty. We know that our audience is really well-versed in machine learning, data science, and mathematics, so we're going to be diving right in.
Sounds good.
So this paper that we're looking at today, DeepSeek V2, it's all about training efficiency, inference efficiency, overall performance with this large language model.
Yeah.
And one of the really cool things about DeepSeek V2 that we're going to be talking about is its architecture. And that includes two new innovations, one called multi-head latent attention, MLA, and the other one called DeepSeek-Mo.
Right.
And one of the things that really impressed me, I'm sure impressed you as well, looking at this paper, is that it was able to achieve top-tier performance, but with a smaller number of active parameters.
Yeah, I think that's one of the most impressive things. They were able to achieve that with this really clever architecture.
So maybe we can start there, talking about how this DeepSeek V2 architecture really addresses some of the fundamental challenges of large language models. As these models scale, they need more and more computational resources.
Right.
And then, of course, the inference speed can kind of, plummet as they get larger and larger.
Mm-hmm.
So this paper, DeepSeek V2, is really about how can we create this large language model that doesn't have those problems.
Exactly. And I think DeepSeek V2 does a great job of, coming up with clever solutions.
So it's got this unique architecture. Can you talk a little bit about these two core innovations, MLA and DeepSeek-Mo, and how they kind of fit into the overall picture?
Sure. So as you mentioned, DeepSeek V2 is based on the transformer architecture, but introduces the MLA for enhanced inference efficiency and DeepSeek-Mo for more efficient training.
Okay.
So the MLA tackles this problem of the key value cache, which can become a bottleneck during inference as the models scale.
Yeah, that KV cache can be a real problem.
Right.
It gets larger and larger, and then all of a sudden your response times are really, really slow.
Exactly.
It seems like they're really trying to avoid that with DeepSeek V2.
Yeah.
And the paper mentions that MLA uses this technique called low-rank key-value joint compression.
Right.
Can you kind of break down how that works and why it's so impactful for inference efficiency?
Yeah, so standard multi-head attention, the MHA, it has a large key value cache during the inference.
Right.
And the idea here is that instead of storing, all of this information in the KV cache, they try to compress this information into a smaller vector called a latent vector.
I see.
So, and then during inference, so what happens is, we use this compressed latent vector and then reconstruct the information needed from the compressed vector.
So it's like a super efficient compression algorithm almost.
Exactly. And they've designed it so that, it doesn't lose a lot of information during this compression and reconstruction process.
That's really impressive. So they're able to maintain that performance, but also get those really fast response times because the KV cache is so much smaller. And the paper even gives us a comparison of MLA's KV cache needs against some of the other methods out there, MHA, GQA, MQA. What are the key takeaways that we can learn from that comparison?
So in Table 1, they compare the KV cache size with MLA, MHA, and also GQA. And what we see is that the MLA needs a KV cache size comparable to GQA with 2.25 groups.
Okay.
But it outperforms GQA significantly, and it is even stronger than MHA in terms of performance.
So it's as efficient as some of these other compression techniques, but then it has the performance of just standard multi-head attention.
Exactly.
Really cool. So that's the MLA, and that's all about the inference side of things. But then on the training side, they've got this other really interesting innovation called DeepSeek-Mo.
Right.
And training these huge, massive language models just takes so many computational resources.
Yes, it's incredibly expensive.
It can be really, really expensive.
Yeah.
So DeepSeek-Mo, how does that fit into the picture?
Yeah, so DeepSeek-Mo is a type of mixture of experts architecture. And the idea here is that, instead of activating all of the model parameters for every single input, they try to route each token to a select group of experts in the network.
Interesting.
So what happens is, each expert kind of specializes and becomes really good at a certain task.
It's almost like dividing and conquering that training process in a way.
Exactly. And DeepSeek-Mo, actually goes beyond the typical MOE approach and utilizes two very important improvements.
Okay.
So the first one is fine-grained expert segmentation, and the second one is shared expert isolation.
Okay.
So what happens is, when you have this fine-grained expert segmentation, each expert becomes even more specialized, and they acquire and utilize knowledge more effectively.
I see.
And then the shared expert isolation ensures that each expert develops its own kind of a unique knowledge base, and it reduces this knowledge redundancy.
Interesting. So it's not just about dividing the work. It's about making sure that the experts are really specialized and that they're not duplicating each other's efforts.
Exactly.
It's kind of a really clever orchestration of that training process.
Okay.
Now, the paper also mentions that they employ some specific techniques to really make this DeepSeek-Mo as efficient as possible. Can you talk about those techniques?
Yeah, so they have three major techniques.
Okay.
The first one is called device-limited routing.
Okay.
The second one is auxiliary losses.
Okay.
And the third one is token dropping.
Okay. So let's unpack each of those. What is device-limited routing, and how does that help with efficiency?
Yeah, so device-limited routing, what this does is it kind of restricts the number of devices each token's data has to travel to.
Oh, I see.
So what happens is that, it limits communication costs and it speeds up the training process.
So it's about kind of optimizing that flow of information during training.
Exactly.
And then auxiliary losses, how do those play a role?
Yeah, so they utilize auxiliary losses to ensure a balanced workload among the experts and also across devices.
So it's kind of preventing bottlenecks and making sure everything's running smoothly.
Right. So some experts, may be overloaded with data, some may not, right?
Yeah.
So these auxiliary losses ensure that, this computation is balanced.
Really smart. And then the third technique, token dropping, what is that all about?
Yeah, so token dropping, what they do is during training, DeepSeek V2 strategically drops tokens, with low affinity scores to some experts.
Interesting.
So what happens is, each expert focuses only on the most relevant information.
Almost like you're focusing their attention on the things that matter most.
Exactly.
Yeah, that makes sense.
And one important thing is this dropping mechanism is also consistent between training and inference so that there is no performance discrepancy.
Oh, that's a really important point. So they're not just doing this during training and then changing things up during inference.
Right.
Okay, so now that we've talked about these innovations in the architecture, let's move on to talking about the data that they use to train DeepSeek V2. This is a massive data set, 8.1 trillion tokens.
Yeah.
So tell us about this data. What's in it, and how do they make sure it was high quality?
Right. So DeepSeek V2 was pre-trained on this massive, high-quality bilingual corpus, comprising English and Chinese text.
Okay.
To ensure data quality, they filtered out the contentious content, to mitigate these potential biases.
Okay.
And this data set is even larger and higher quality than the one they use for DeepSeek 67B.
I see. So they're really focusing on that data quality aspect as they build these models.
Right. And also they utilize the HAI LLM framework.
Okay.
And employed a sophisticated combination of pipeline parallelism, expert parallelism, and also 0-1 data parallelism to handle the training of such a large model.
Wow, that's a lot of parallelism.
Yeah.
So it sounds like they really had to bring out the big guns to train this model on such a massive data set. Now, the paper also mentions that they extended the context length from 4K to 128K tokens.
Right.
How did they achieve such a significant extension?
Yeah, so they use this technique called yarn.
Okay.
And specifically applying yarn to this decoupled shared key in the MLA architecture.
Okay.
So yarn is designed to extend the context window of transformer-based models, and they made some specific adjustments to suit the DeepSeek V2 architecture.
Interesting. So this yarn technique allows DeepSeek V2 to process much longer sequences of text.
Right.
And the paper mentions these needle in a haystack tests. Can you explain what those tests are and what they tell us about DeepSeek V2's ability to handle these long context lengths?
Sure. So as you mentioned, they use this needle in haystack, the NIAH tests. It evaluates the model's ability to recall information from these long sequences.
Okay.
And in these tests, they try to hide some relevant information within a much larger context.
Right. And DeepSeek V2 was able to successfully retrieve the crucial information from these longer pieces of text, indicating a good understanding of these long-range dependencies.
That's really impressive. So it's not just about processing longer pieces of text. It's actually about understanding the relationships between different parts of that text, even if they're far apart.
Exactly.
Really, really cool. So we've talked about the architecture. We've talked about the data, all this kind of groundwork. But now let's get to the really exciting part, which is the results.
Right.
How did DeepSeek V2 perform?
So they did a pretty comprehensive evaluation across English and Chinese benchmarks.
Okay.
They tested on multi-subject, multiple choice questions, language understanding, reasoning, closed book question answering, reading comprehension, reference disambiguation.
Wow, that's a lot of different benchmarks. So they really wanted to make sure that they were covering all their bases here. Yeah, and they even went beyond the traditional language tasks, and they also tested it on things like language modeling, math problem solving, code generation, and even standardized exams.
Wow, so they really threw everything at it. And how did it perform against other open source models?
Yeah, so they compared it with DeepSeek-67b, Qwen 1.572b, Mixtral 8x22b, and Lam A3 70b. And DeepSeek V2 consistently achieved top-tier results, often outperforming models with significantly more active parameters.
So even though it was smaller, it was still able to outperform a lot of the competition.
Exactly. And again, this really highlights the efficiency in utilizing these 21 billion active parameters.
Yeah, it seems like they've really found a way to do more with less. Are there any specific areas where DeepSeek V2 really excels?
Yeah. So they found that DeepSeek V2 particularly shines in English language tasks, code generation, and math problem solving.
Interesting.
While its performance on certain Chinese benchmarks may be slightly weaker, it demonstrates a very strong overall capabilities.
Right.
So it's, really good in a lot of these key areas.
So they've built a really strong model. It's very efficient. It performs well. What about the efficiency gains that they were able to achieve?
Right. So, as I mentioned, they were able to get a 42.5% reduction in training costs compared to DeepSeek 67b.
Wow, that's a huge savings.
Yeah, and, this is mainly due to the smaller number of active parameters and also the DeepSeek-Mo architecture.
Okay.
And in terms of inference efficiency, DeepSeek V2 achieves a very impressive generation throughput of over 50,000 tokens per second on a single node with 8 H800 GPUs.
Wow, that's fast.
And this is a 5.76 times speed increase compared to DeepSeek 67b.
So they've really seen some substantial gains there, both in training and inference efficiency.
Right.
Now let's move on to talking about DeepSeek V2 Chat, which is this conversational version of the model. What can you tell us about the fine-tuning process that they use to create DeepSeek V2 Chat?
Right. So to create DeepSeek V2 Chat, they utilized this supervised fine-tuning, the SFT, and also reinforcement learning, the RL. And they trained the model on a data set of 1.5 million instruction tuning instances.
Wow, that's a lot of data. So they're really feeding it a lot of examples of conversational data.
Right. So, basically they're trying to teach the model how to follow instructions and engage in more human-like conversations.
I see. Can you talk a little bit more about how they used reinforcement learning in that fine-tuning process?
Yeah, so they used an algorithm called Group Relative Policy Optimization, or GRPO, for the RL phase.
Okay.
And GRPO is an algorithm that directly optimizes the policy model.
Okay.
And it is much more efficient for training large models compared to these traditional RL algorithms.
So it's kind of streamlining that reinforcement learning process.
Right. And they also utilized a two-stage training strategy, focusing first on reasoning alignment and then aligning the model's responses with human preferences.
Oh, that's interesting. So they're making sure that it's not just reasoning correctly, but also responding in a way that's consistent with human preferences. Now, I'm guessing that doing reinforcement learning with a model of this scale, it probably presented some challenges, some engineering challenges.
Absolutely. It was a significant engineering challenge.
What were some of those challenges and how they overcome them?
So they came up with some very clever optimizations to make this training process more manageable.
Okay.
And one of the innovations was a hybrid engine.
Okay.
So this hybrid engine, it adopts different parallelization strategies for training and inference.
Okay.
And they're able to maximize the GPU utilization and speed up the process.
So they're getting the most out of their hardware. That makes sense.
Right. And also, they utilize this library called VLLM, which is a library designed for accelerating large language model inference.
Okay.
And by using VLLM with large batch sizes, they achieved substantial speedups in response generation.
So a combination of really smart algorithms and then also optimizing their infrastructure to handle these demands.
Yeah.
Now, memory management must have also been a challenge with a model of this size. How did they handle that?
Right, so they implemented a CPU offloading scheduling strategy to manage memory efficiently.
Right.
So parts of the model were strategically offloaded to CPUs and then loaded back to GPUs when needed.
Oh, that's a clever way to kind of balance things out.
Mm.
Did these optimizations lead to any actual improvements in DeepSeek V2 Chat's performance?
Yeah, so they actually did see some very significant performance gains, after implementing these optimizations. The RL training significantly enhanced the model's ability to generate responses that are aligned with human preferences, particularly in terms of helpfulness, safety, and the ability to follow instructions. And they also conducted some very thorough evaluations to actually assess the effectiveness of these alignment techniques.
That's great to hear. So it sounds like they've really put a lot of effort into not just making this model conversational, but also making sure that it's safe, it's helpful, it aligns with user expectations. What were some of the key findings from those evaluations? How did DeepSeek V2 Chat stack up?
So DeepSeek V2 Chat with SFT showed improvements over the base model on tasks involving reasoning, code, and math. And DeepSeek V2 Chat with RL further enhanced performance on these benchmarks. And they also observed very significant performance gains on these open-ended conversational tasks. DeepSeek V2 Chat with RL surpassed other open-source models on benchmarks like MTBench and Outpacable 2.0.
That's really impressive. So they've created a model that's conversational, but it also maintains that high performance across a variety of tasks. Now, of course, no model is perfect. What are some of the limitations that they acknowledge in the paper?
Yeah, so they do acknowledge a couple of limitations. So like many current LLMs, DeepSeek V2 lacks a mechanism for continuously updating knowledge after pre-training. So, after pre-training is done, the knowledge is kind of fixed.
Right.
And also, it can be prone to generating hallucinations, responses that sound plausible but are factually incorrect.
That's a common problem with these large language models.
Right.
And then also, its language proficiency is primarily limited to English and Chinese.
Right.
Okay, those are some important limitations to be aware of. What about biases? Do they encounter any specific biases in the model's outputs?
So while they implemented measures to mitigate bias during the data collection and the pre-training phases, they acknowledged that DeepSeek V2 might still exhibit some biases that reflect those present in the training data.
Right, it's really hard to completely eliminate bias.
Yeah. They don't go into specific examples of biases observed.
Okay.
But, they do emphasize the importance of being aware of these potential biases and interpreting the outputs with a critical eye.
So despite these limitations, it's clear that DeepSeek V2 is a significant step forward. What are some of the exciting future directions that they hint at in the paper?
So they highlighted several areas for future research. They want to further scale these MOE models, and they want to improve alignment techniques. They also want to expand to multimodality support.
Multimodality support, that's really interesting. What would that look like for DeepSeek?
So they envision DeepSeek being able to process and generate not just text, but also images, audio, and potentially even video.
So it's like a model that can understand and create in all these different media formats.
Exactly. This opens up a whole new realm of possibilities.
Wow, that's pretty mind-blowing. What are some of the potential applications they envision for a multimodal DeepSeek?
So they're thinking about things like content creation tools that can generate realistic videos from text descriptions.
Wow.
Educational platforms that can offer immersive and interactive learning experiences.
It's like breaking down those barriers between different types of media.
Exactly. And also, AI-powered personal assistants that can understand and respond to our needs in a much richer and more intuitive way.
Yeah, it's like they're really moving towards this idea of AI that can interact with the world in a much more human-like way.
Exactly. And they believe that DeepSeek V2, with its robust architecture and the impressive efficiency, provides a very solid foundation for exploring these capabilities.
I think it's really exciting to see where they go with this. So they're not just content with what they've achieved, they're really pushing the boundaries. Now, as we start to wrap up this part of our deep dive, what are some of your key takeaways? What really stood out to you about DeepSeek V2?
So I think DeepSeek V2 really represents a very significant step forward in large language model development. They're pushing the boundaries of performance and efficiency while also acknowledging the importance of responsible AI development.
Right.
The innovations in its architecture, the training techniques, and the alignment strategies, they offer some very valuable insights for future research and applications.
Yeah, and I think it's really exciting to see a model that's not just powerful, but also very thoughtfully designed with these ethical considerations in mind.
Yeah.
What are you most excited about in terms of the potential impact of DeepSeek V2?
I think I'm personally very excited about this. Their plans for multimodality support.
Yeah, that's a game changer for sure.
It could revolutionize how we interact with AI.
It's like we're moving towards this future where AI is not just this kind of separate entity, but it's really integrated into the fabric of our lives.
Exactly.
And DeepSeek V2 is a big step in that direction.
Definitely. DeepSeek V2 also excels in tasks that require, high degree of logical reasoning, such as code generation and math problem solving.
Yeah, those results in those areas were really impressive. Can you talk a little bit more about the specific benchmarks they used and what the findings were?
Sure. So for code generation, they evaluated DeepSeek V2 on Human Evol, MBPP, and CRU-X Evol.
Okay.
Human Evol tests a model's ability to generate functionally correct code from these natural language descriptions.
Okay.
MBPP focuses on Python code generation.
Okay.
And CRU-X Evol assesses the model's code generation capabilities on these more complex tasks.
So it's a really diverse set of benchmarks to assess the model's coding prowess. How did DeepSeek V2 do on those tests?
So DeepSeek V2 demonstrated a very strong performance on all three code generation benchmarks. It achieved respectable scores on Human Evol, showing proficiency in understanding the instructions and translating them into working code. And its performance on MBPP further solidified its code writing capabilities. And on CRU-X Evol, it successfully tackled the more intricate code generation challenges.
Really impressive. Sounds like DeepSeek V2 has a real knack for coding.
Yeah.
What about its math abilities? What benchmarks did they use to evaluate its math problem-solving skills?
Right, so they assess DeepSeek V2's math capabilities on GSM-8K, math, and CMath.
Okay.
GSM-8K consists of grade school level math problems.
Okay.
Testing the model's ability to solve multi-step problems. Math involves more complex math problems requiring a deeper understanding of mathematical concepts.
Okay.
And CMath is a Chinese math data set assessing the model's multilingual proficiency in mathematics.
So good mix of benchmarks there to really gauge its mathematical reasoning across different levels of complexity in languages. What were some of the standout results in this domain?
DeepSeek V2 exhibits very impressive accuracy on GSM-8K,
Go on.
demonstrating its ability to reason through multi-step problems, and also achieved commendable score on math, handling the more advanced mathematical concepts. And also the performance on CMath proves that its multilingual prowess extends to math problem solving.
That's incredible. So it really sounds like DeepSeek V2 is a true polymath, excelling in both, the logical rigor of coding and then the abstract reasoning of mathematics. What are some of the implications of these capabilities?
Yeah, definitely. DeepSeek V2's strong performance in code and math tasks hints at its potential to revolutionize various fields.
Right.
So imagine AI assistants that can not only write simple scripts, but also develop complex software, or AI tutors that can provide personalized math instruction.
It's a really exciting glimpse into a future where AI can really augment human capabilities in profound ways. Shifting gears a little bit, let's dig a little deeper into the efforts they made to ensure DeepSeek V2 is aligned with human preferences and values. We talked about this a little bit earlier, but I'd like to explore it in a bit more detail.
Yeah, alignment is indeed a crucial aspect of developing these powerful AI systems.
Right.
And as we discussed, they used both supervised fine-tuning the SFT and reinforcement, learning the RL to train this DeepSeek V2 chat, the conversational variant of the model.
Okay.
But it's not just about the technique, the data, and the specifics of their implementation also plays a significant role.
Yeah, the devil is in the details.
Yeah.
Can you elaborate a little bit on their approach to SFT and how they ensured that the training data actually reflected human preferences?
Sure. So for SFT, they curated a data set of 1.5 million conversational instances.
Okay.
And this data set included examples of both helpful and safe responses, reflecting human expectations in conversational settings.
Boy.
The model underwent 2 epochs of training on this data set, learning to engage in more natural and engaging dialogues while adhering to these ethical guidelines and avoiding harmful, offensive language.
Yeah, that's a massive data set. The emphasis on helpfulness and safety is really, really important. Now let's talk about the RL phase. How did they use RL to further align DeepSeek V2 chat with human preferences?
So for RL, they employed an algorithm called Group Relative Policy Optimization, or GRPO.
Okay.
And unlike traditional RL algorithms that require a separate reward model, GRPO leverages this group scores to directly optimize the policy model, making it very efficient for large-scale models like DeepSeek V2.
So it streamlines the RL process, making it more suitable for these massive models. Can you explain a little bit how GRPO works in practice, especially in the context of aligning DeepSeek V2 chat with human preferences?
Okay, so imagine a group of responses generated by the model, right?
Okay.
GRPO assigns a reward to each response based on how well it aligns with human preferences.
Okay.
And these preferences might encompass factors such as helpfulness, factuality, clarity, adherence to ethical guidelines.
Right, so it's almost like having a panel of judges who are evaluating each response and assigning a score based on how well it meets these certain criteria, and then GRPO uses those scores to guide the model's learning process.
Exactly. So based on these rewards, GRPO updates the model's parameter, encouraging it to generate responses that are more likely to receive higher scores in the future.
So it's a way of really fine-tuning the model's behavior to be more aligned with what humans expect and prefer.
Right. And in addition to that, they also implemented this two-stage RL training strategy,
Okay.
focusing first on aligning the model's reasoning abilities with human expectations, and then refining its ability to generate responses that are consistent with human preferences in terms of helpfulness, safety, and rule adherence.
That's really interesting. So it's a two-pronged approach to RL alignment, addressing both the logical and the ethical aspects of the model's behavior. Now, given the scale of DeepSeek V2, I imagine training it with RL must have presented some pretty significant engineering challenges.
Yeah, absolutely. Training a model of this magnitude with RL requires overcoming very substantial computational hurdles. They discuss several optimizations they implemented to actually make the RL training process manageable.
Yeah, I'd love to hear about some of those optimizations. What were some of the key strategies they employed?
So one of the primary innovations was this hybrid engine
Okay.
that adopts different parallelization strategies for training and inference.
Okay.
So this dynamic approach actually maximizes GPU utilization, significantly speeding up the process.
So they're really squeezing the most out of the hardware.
Right. And they also leverage VLLM, a library specifically designed for accelerating inference of large language models.
Okay.
And by using VLLM with these large batch sizes, they achieved very substantial speedups in response generation during RL training.
So this is a really nice synergy between the algorithm and the infrastructure.
Right.
What about memory management? I imagine training a model of this scale must really push the limits of memory resources. How did they handle that aspect?
Right. So they addressed the memory challenge by devising the CPU offloading scheduling strategy.
Okay.
And this strategy involved offloading parts of the model to CPUs and then loading them back to GPUs when needed.
Okay.
So this dynamic allocation of memory resources actually ensured a very smooth and efficient training process.
Really clever. It sounds like they've really taken this holistic approach to optimizing the RL training process, addressing both the hardware and the software considerations. Did these optimizations translate into any actual performance improvements in DeepSeek V2 chat?
Yeah, so they observed substantial performance gains after implementing these optimizations.
Okay.
The RL training significantly enhanced the model's ability to generate responses that are aligned with human preferences, particularly in terms of helpfulness, safety, and the ability to follow instructions. And they also conducted very thorough evaluations to assess the effectiveness of these alignment techniques.
I'm eager to hear about those evaluations. What benchmarks did they use, and how did DeepSeek V2 chat perform compared to other conversational AI models out there?
So they evaluated DeepSeek V2 chat, both the SFT and RL versions, on a range of standard and open-ended benchmarks.
Okay.
And they compared its performance with other popular chat models, including Qwen 1.572B chat, Liang 370B instruct, and Mistral 8x22B instruct to gauge its capabilities relative to these other state-of-the-art models.
It's like they really put DeepSeek V2 chat through its paces. What were some of the key takeaways from those evaluations? Did DeepSeek V2 chat stand out?
So the evaluations revealed that DeepSeek V2 chat, particularly the RL version, demonstrated strong performance across a range of conversational tasks.
Okay.
It showed significant improvements over the base model and also often outperformed these other open source models, particularly on tasks involving reasoning, code generation, and math problem solving.
So they were able to make it conversational, but it still retained those really impressive capabilities in logic and reasoning.
Right.
Now, no models without its limitations. Do they discuss any potential drawbacks or challenges associated with DeepSeek V2 and its alignment techniques?
Yeah, so they do openly acknowledge that DeepSeek V2, like many other large language models out there, is susceptible to certain limitations and also potential biases.
Okay.
And they also discuss this phenomenon called alignment tax, where the efforts to align a model with human preferences can sometimes lead to a decrease in performance on these standard benchmarks.
That's an interesting concept. It suggests that there might be a trade-off between achieving alignment and maximizing performance on certain tasks. Can you elaborate a little bit on how this alignment tax manifested in DeepSeek V2 chat?
Yeah, so they did observe instances where DeepSeek V2 chat's performance on benchmarks that focused on tasks such as question answering and logical reasoning was slightly lower after alignment training.
Interesting.
It seems that focusing too heavily on this conversational fluency and safety may have come at the cost of slight reductions in performance on these more objective tasks.
So it's this delicate balancing act where they're trying to make it both conversational and capable. Sometimes those two goals might be a little bit at odds with each other. Did they offer any potential solutions or strategies for mitigating this alignment tax?
Yeah, so they do acknowledge that mitigating this alignment tax is an ongoing challenge and an active area of research in the field.
Right.
They emphasize the importance of carefully curating and balancing the training data, and also exploring these alternative alignment techniques that might minimize this trade-off between alignment and performance.
That makes sense. So it's really about finding that sweet spot where you can have both alignment and performance. Now let's talk a little bit about some of the specific limitations and potential risks associated with large language models in general, like DeepSeek V2. Earlier, you mentioned potential biases. Can you expand on that a little bit?
Yeah, so while they implemented measures to mitigate bias during the data collection and pre-training phases, they recognized that DeepSeek V2 might still exhibit biases reflective of the training data. They emphasized the importance of being aware of these potential biases and interpreting the model's outputs with a critical eye.
That's a really crucial point.
Yeah.
Even with the best of intentions, eliminating all biases from a model trained on such massive data sets is an incredibly difficult challenge. What other limitations did they highlight?
They acknowledge that DeepSeek V2, like most current large language models, lacks a mechanism for continuously updating its knowledge base after pre-training.
Okay.
So this means its knowledge is static and might become outdated over time.
Right, it's kind of a snapshot of knowledge at a particular point in time. It can't keep up with the ever-evolving world of information. What other potential drawbacks did they discuss?
They also pointed out this potential for hallucinations, where the model might generate responses that sound very plausible but are factually incorrect or even completely fabricated.
Yeah, that's a concern. If people are taking these fabricated responses as fact, it could lead to misinformation.
Right. And they stress the importance of verifying the information generated by the model, especially if it's being used in situations requiring accuracy and reliability. And they also acknowledge that DeepSeek V2's language proficiency is primarily limited to English and Chinese, so restricting its applicability in multilingual contexts.
So, while DeepSeek V2 has all these really impressive capabilities, it's important to be aware of its limitations
Right.
and use it judiciously. Now, despite these limitations, it's clear that DeepSeek V2 represents this really significant advancement in the field of large language models. What are your thoughts on the broader implications of this work?
DeepSeek V2 showcases the rapid progress being made in AI, pushing the boundaries of what's possible with large language models. And its innovations in architecture, training, and alignment have very far-reaching implications for various fields.
Yeah, it's really exciting to be witnessing these advancements unfold. What are some of the most promising directions for future research and development building on the foundation laid by DeepSeek V2?
So they outline several ambitious goals for the future of DeepSeek. They aim to further scale MOE models, they want to enhance alignment techniques, and they want to expand to multimodality support,
Wow.
enabling the model to process and generate content across text, images, audio, and potentially even video.
That's amazing. Those are some really ambitious goals. Given their track record, I'm sure they'll continue to make really significant strides. And their commitment to open source development is also really commendable.
Yeah.
It's going to allow others to build upon their work and really foster that collaboration and accelerate the progress in the field. Now, we've covered a lot of ground in this deep dive, exploring the intricacies of DeepSeek V2, its capabilities, limitations, and potential impact. What stands out to you as the most impressive aspect of this work?
For me, it's this harmonious blend of innovation and practicality they've achieved. So DeepSeek V2 is not just a theoretical marvel. It's a model designed with real-world applications in mind.
Yeah, I completely agree. They really struck this remarkable balance between pushing the boundaries of what's possible and then ensuring that their creations are also aligned with human values and goals.
Exactly. DeepSeek V2 is not just a technological achievement. It's a testament to the potential of AI to be this force for good in the world.
Really well said. This deep dive into DeepSeek V2 has been incredibly enlightening. We've learned so much about this groundbreaking model, its potential applications, and the broader landscape of AI research. And as always, I'm left with this sense of wonder and excitement about what the future holds for this rapidly evolving field.
Me too. It's a privilege to be part of this technological revolution.
It really is. And thanks to DeepSeek's commitment to open source development, researchers and developers around the world can now build upon this foundation laid by DeepSeek V2, accelerating the pace of innovation and bringing us closer to a future where AI enhances our lives and helps us solve some of humanity's most pressing challenges.
Absolutely. It's a testament to the power of collaboration, open knowledge sharing, and the belief that AI should be a force for good in the world.
Well, on that inspiring note, I think it's time to wrap up this deep dive.
Indeed. I have thoroughly enjoyed our exploration of DeepSeek V2.
Me too. And I'm sure our listeners gained some valuable insights as well.
Yeah.
Thanks for joining us on this journey into the fascinating world of large language models.
Until next time.
It really is remarkable how they've managed to achieve that balance of, pushing the boundaries of what's possible with these models while also being very mindful of those ethical implications.
Yeah, it's not just about performance.
Great.
It's also about responsibility and making sure that these models are used for good.
Exactly. And I think that's what makes this research so compelling.
Absolutely.
And it's not just an academic exercise. It's a step towards making AI a practical and beneficial tool for everyone.
Yeah, and it's exciting to see a team that's really dedicated to that vision.
Speaking of practical applications, I'm really intrigued by their vision for multimodality support in the future versions of DeepSeek.
Oh yeah, that's a game changer.
The idea of an AI that can seamlessly handle text images, audio, and even video, it's pretty mind-boggling.
Yeah, the possibilities are endless.
What are some of the use cases that come to mind when you think about a multimodal DeepSeek?
Well, you could have content creation tools that could generate realistic videos from text descriptions.
Wow.
You could have educational platforms that offer these immersive and interactive learning experiences.
That'd be incredible.
Even AI-powered personal assistants that could understand and respond to our needs in a much richer and more intuitive way.
It's like we're breaking down the barriers between different forms of media
Yeah.
and allowing for this more natural and fluid interaction with AI.
Exactly. And I think DeepSeek V2, with its robust architecture and impressive efficiency, it provides a very solid foundation for exploring those capabilities.
It's really fascinating to think about how these advancements could reshape industries and our lives as we know it.
Yeah, it's a very exciting time to be working in this field.
As we wrap up this deep dive, what are your key takeaways from our exploration of DeepSeek V2?
Well, DeepSeek V2 is a testament to the rapid progress being made in the field of large language models.
Right.
It showcases the power of innovative architectures, efficient training techniques, and thoughtful alignment strategies.
Yeah.
But beyond those technical achievements, what I find most compelling is the team's commitment to responsible AI development.
Yeah, I agree with that.
They've not only pushed the boundaries of what's possible, but they've also acknowledged the limitations and potential risks associated with these powerful AI systems.
Their transparency and willingness to discuss those ethical considerations is really commendable.
Absolutely. It's a positive example for the entire field.
What are your thoughts on the future of large language models, especially given the advancements that we've seen with DeepSeek V2?
I think we're on the cusp of a transformative era in AI.
Yeah.
Large language models are becoming increasingly capable, versatile, and accessible.
Right.
And we're already seeing their impact in various domains.
Yeah, definitely.
And as these models continue to evolve, we can expect even more groundbreaking applications that will fundamentally change how we live, work, and interact with the world around us.
I think that's a very exciting and thought-provoking perspective.
Yeah, it's definitely a time of great change and innovation.
And with DeepSeek's commitment to open source development, these advancements will be accessible to researchers and developers worldwide, fostering that collaboration and accelerating progress.
Absolutely. Open source development plays a vital role in democratizing AI and ensuring that these powerful technologies benefit all of humanity.
Well said. This deep dive into DeepSeek V2 has been an incredibly enlightening journey. I've gained a much deeper appreciation for the complexities of large language models, the incredible potential they hold, and the importance of responsible AI development.
It's been a pleasure delving into these topics with you.
Likewise.
The world of AI is constantly evolving, and it's exciting to witness these groundbreaking advancements unfold.
It really is, and I'm sure our listeners share our enthusiasm for this rapidly evolving field. Thank you for joining us on this deep dive into the fascinating world of DeepSeek V2.
Until next time.